There's the direct attack and overflow thing. Okay, so Mike Lynn isn't here. If anyone else comes up with a direct overflow in a major like infrastructure iOS, I'll be really impressed. But I think we're going to see more of that coming as the reverse engineers get cracking on these infrastructure devices. And finally, there is routing manipulation, which requires a little bit more knowledge of what's going on, what protocol they're using, how it authenticates, and if it broadcasts or just accepts data from anywhere. But we'll get into that a little bit later. That one's fun. All right, so boring stuff first. Weak passwords. Defaults everywhere. The PhenoElite guys have a fantastic, gigantic list of the default passwords for almost every device you are likely to come across. And so if you Nmap SV something and you find out that it's some bizarro box you never heard of, give that list a look. It's worth it. You will occasionally luck out and find the defaults. And I found that the weirder the piece of equipment is, the more likely you are to find the defaults on it. Like, a lot of people, they get something that they don't really understand. It's like, some Bay router switch from 1995, and they're just, okay, whatever, plug it in, leave it alone, that's hard, we're going to not touch it. And a lot of administration folks don't think that they need to limit the access to these devices, which is obviously bad. In an ideal world, and we'll talk about this a bit in the defense section, but only the people who are managing your network should be able to talk to your routers and switches directly. I mean, anyone who's on the segment should be able to pass packets through according to its policy, but, Joe Bob and Jane Bob out there do not need to be SSHing into my router. They've got no call for that. And there are still many major ISPs that have their ports open to the entire internet, which is just stupid. If you manage to get an encrypted password for these devices, say you maybe own an end station or something and it's got the configuration backups for the backbone, that happens a lot too. For the simple authentication, like Cisco has this old encryption called 7 encryption, and it's ghetto. I mean, you can decode it on a napkin. It is bad. There are web pages out there, and they said that it wasn't actually intended to be encryption. It was just so that shoulder surfers wouldn't actually see your password. But if people are depending on that for security in their configuration, they really shouldn't. A lot more vendors are going towards MD5 passwords, and the nice thing about those is that even if you get enough access to the routers that you can see the config or you find a config file somewhere, you can just pull out the MD5 hash and format it and throw it into John the Ripper just like a FreeBSD line or a Unix line, and boom, it'll crack it just the same. So if they have rotten passwords, good for you. And of course there are programs like Hydra or Cisco Torch that we mentioned earlier that will allow you to attack them directly. Web and admin interfaces. Try your basic cookie manipulation, because a lot of them will depend on that. There was one custom app that, swear to God, it set a cookie and said logged in equals false. So I changed the cookie to logged in equals true, and oh my God, I had admin on their entire devices. It's just bad. So a lot of these things that you already know how to do that you don't think might work, give it a shot. They might just work. There are various little admin protocols that different kinds of devices use, and most of them have not been very well thought out. They'll use kick and encryption like XOR or ROT13, and you have, the ability to reverse that pretty quickly. There's this nice little Firefox extension called LeapKey that you can just highlight something and then you can manipulate it in like 8 different ways, and it's just worth checking sometimes. Was that a question, or you just... Okay, cool. And another thing, with passwords and the web interfaces, people reuse passwords all the time. If you get one somewhere in a pen test, try it on the backbone. You never know. And if you have an intelligent cracker, feed everything that you've got into that so it will try permutations of those passwords, because there have been plenty of times when the server password is I'm so cool and the backbone password is I'm so cool 42. So yeah, not really so cool. Social engineering with a backbone spin. And I don't know much about the European laws. Many places in the US are trying to pass laws to outlaw doing this sort of thing. So, You know, if you're doing this professionally, make sure that you're not going to get your company in trouble. But a really commonly successful one is to call up some junior admin, tell them that you're from the registrar and that you need to validate that they're using all their IP addresses or you're going to take them away. And they freak out and get upset and you say, all right, let me log into one of your routers, I'll dump the routing table and we'll make sure that you're using everything you say. And they go, huh, okay. Yeah. And for anything that requires physical access, you know, a shiny telecommunications company hat goes a really long way. One of the companies I worked for had a suite of uniforms. We had the FedEx uniform, we had the telephone company uniform, we had the generic office girl uniform, and especially if they, you know, happen to be having an outage because someone unplugged their line at the DMARC, then they're very happy to see you and they'll just let you right in. But social engineering, other people can do whole giant talks on that. So one of my favorite things to do is to hijack the authentication server. And almost without exception, these things tend to run on multi-purpose boxes that are doing 10 million things, and they're not really in well-protected areas of the network. Now, for any of you that have done network design, this is obviously dumb. However, it's also what happens. You know, people think of Radius and they think of TACACS and they're like, oh yeah, it goes on our utility box, and it just gets thrown on something ancient. So it is worthwhile trying to discover, and if you can port scan, and if you have access and you're not blocked by a firewall, and then you can see the ports open on these, so it's not exactly hard to pick it out. Or if you notice that you're trying to go to a web page and you're getting redirected, and you can see, like, from the redirection box, sometimes if you can pop that one, where it's going to and get the authentication server. So your standard pen tester's toolkit will help you out for that. And if you own the authentication server, you're golden. You can grant yourself access to anything that queries it, and sometimes a little bit more. You know, again, with the social engineering, there was one pen test where my team and I owned the authentication server, but only about half of their boxes were authenticating to it. So we sent out an email from the email server that we had compromised saying, all right, everyone must move to the new standard. All of you guys have to roll out TACACS by the end of next week. And they did it, and so we had the whole network. You know, don't underestimate the power of having central authentication. You know, it's great for administrative control, but you really want to make sure that that box is well protected or bad things happen. And authentication servers also are often very, very prone to denial of service attacks. You know, again, the ancient box running 20 million services, that tends to help. But even if you look up TACACS or Radius or a lot of the other common auth servers, just throw it into the open source vulnerability database, you'll get tons and tons of stuff coming back. And if you can get access to the physical segment, you can have your own little authentication server ready to go. So you knock theirs offline, you light yours up, and there you go. You are now in charge of who gets where for the whole network. And we've done that pretty successfully. If you have wireless, this is so much easier. You can sit in the parking lot and do it. They're not fond of that. And this sort of tactic will also work for other devices like your edge routers. You know, if you want to make sure that you intercept a certain type of traffic, you can insert yourself into the middle by DOSing the router and assuming that you have an uplink to send them to, then passing traffic through your laptop. Also worth noticing, a lot of places will have a failover path, and they will spend what security money and time they have on the main path. But if they have to switch over to their backup failover, then that may not be as well protected. So if you can trigger a failover, then you can have an easier time of attacking. So, protocol sniffing. I don't imagine that many of you were in New York last summer, but I did a really interesting bit of research with a couple of friends of mine where we solicited PCAPs from people who had done war driving, and we parsed through the results looking for backbone protocol specifically. Now, this is not something that you should expect to see in people's random wireless captures. Unfortunately, we came across quite a bit of that, and we saw probably about 1% of the traffic was backbone or management traffic. And that's not a huge number, but its impact is disproportionate. I mean, we saw people with their passwords for these routing protocols. We saw really bad passwords that should not have been allowed out. And we responsibly went through and told people. And in one absolutely stellar case, I got a reply that said, well, you can't expect us to change that password. That's in deployment globally. It would be very hard for us to change that very important password that you've got totally sitting in clear text on your laptop and in your slides. So, yeah, you wouldn't expect wireless to be successful, but a lot of people are now placing it in important points, and they don't realize that when you have a routing protocol running, you should set it to passive on the interfaces that are just facing the edge network, so it's not speaking routing protocol out that interface, because if it is, it's advertising not only what routing protocol you're using and what version of it, but a lot of the time, if there is any sort of authentication, it's clear text right in the packet. So I can read it and go, oh yeah, sure, I'm going to join the Minerva network too. And it works. Also, a lot of the routing protocols that are out there, they find other routers by using broadcast. So it's not like, except for BGP where you actually have to say, this is my neighbor, I'm going to set up a BGP session between me and this router over here. Most of the other routing protocols are just like, okay, anyone speaking OSPF? Anyone Minerva? Minerva? Polo? Bueller? And anyone who speaks with that same clear text token back to them is now allowed to, according to whatever policy they've got, which is usually not much, add routes. And that can be destructive or interesting in a variety of ways that we'll get to. So, direct attack and overflow. It's possible. A guy named Mike Lynn demonstrated it, not this past summer, but the one before at Black Hat, and he had a working exploit against a router remote overflow. We haven't seen any other public ones since then, but people certainly try things. Like even 7 or 8 years ago when I was working Backbone ISP stuff, we saw weird things in our logs that didn't really make sense and shouldn't have been. And I don't think that they were necessarily actual overflows, but I think someone was sure trying. Good sources for looking at those are memory management bugs. Like the IPv6 flaw that Mike Lynn exploited was a mishandling of the heap. And there are watchdog processes within a lot of these operating systems that will go back and check and say, is my heap corrupt? Oh my God, it is. I'm totally going to crash. But those can be subverted. Lynn managed to do it, and Cisco has fixed their internals since then, but there are other people working on that kind of thing. The other problem, so any memory management bug is a likely candidate to start trying at least. They're not all going to work obviously, and you have to be able to defeat the heap checker, whatever stack protection mechanisms there are in the operating system you're attacking. But it's still worth investigating. And the other problem is that a lot of these systems will take existing code and incorporate it in. So when someone finds a flaw in, say, OpenSSL, many infrastructure vendors who have incorporated the OpenSSL code, now they all have to patch, and they're usually not as fast as OpenSSL. And there are sometimes this big delays in the incident response coordination because, some big, huge, important 100-pound gorilla has not gotten their act together, and so they don't want to release until everyone's ready to patch, but sometimes it takes a long time. And if you look at the versions of the software that are included in a lot of the infrastructure operating systems, they're usually pretty behind. And so bugs that will work against the main code base with relatively small modification can often be made to work against the embedded devices as well. So, routing manipulation. Here's the fun stuff. So if you can peer with a router, you can usually manipulate the routing tables. Now, it is possible for admins to set routing policy and say, I'm only going to accept these routes from this guy, and I'm only going to accept these other routes from this person, and I'll announce my routes to Joe over here, but I'm not going to listen to anything he has to say. But in practice, the people who do that are usually the large ISPs, and they mostly only care about BGP. The internal routing protocols that are only within your own network, those are supposed to be trusted, and so a lot of people will just trust them blindly. They'll either divide them into areas and use that for like management and segmentation, or they'll just assume that everything internal is okay. And there are fine suites out there that will allow you to run